All right, so we're now at question for June 2018 CSEC paper 2. And the question 4 starts by saying the function f with domain, the domain A is equal to 1, 2, and 3. So these are the domain figures. Is given by f of x is equal to half x minus 3. And they ask us what is the value of f of 1. So when they ask us what is the value for f of 1, all it is saying is wherever in the original equation you see x, you're going to replace it with 1. So when we have, so the original equation was f of x is equal to a half x minus 3. And guys, I'm just rewriting this from what was given in the question. So now we're doing f of 1. So therefore, f of 1 is equal to half multiply by 1 minus 3. You should be following me. Because all I did was just to wherever I see x, I replace it, substitute with the number 1. And now a half multiply by 1, and what you'll get back is a half. So therefore, f of 1 is equal to a half minus 3. And now what we're doing is solving. There are different ways you can work this. I'm going to work it using the fraction method just for us to practice. So what we'll get is f of 1 is equal to, finding the LCM, it will be, LCM is 2, so therefore 2 into 2 goes 1 time 1 multiplied by 1 is 1, and 1 into 2 goes 2 times, and 2 multiplied by negative 3 will give us negative 6. And what we have is now 1 minus 6 to give us minus 5 over 2. And that is our answer, which can then be broken down. So we have f of 1 is therefore negative 5 over 2, which is the same as negative 2.5. So right there, what we're doing is to change our mixed fraction or improper fraction to mixed fraction. So the negative 5 over 2, we say 2 into 5, 2 into negative 5 will leave us with negative 2.5. And that is our answer for question 1, for part 1. Part 2 now says find the value of x when f of x now is equal to negative 2. So we know that f of x is equal to half x minus 3. They're now telling us if f of x is equal to negative 2, solve or find the value for x. So I'm not seeing anyone.
Okay, I understand.
Okay, good. That's good. So that is it. So therefore, what we'll have is, so from the original, what you know is that f of x, this is the original equation I'm writing back, original function, which is a half x minus 3. F of x, they said, is negative 2. So negative 2 is equal to a half x minus 3. So we're now solving for x. So we're going to add 3 to both sides of the equation. So what we'll have is minus 2 plus 3 is equal to a half x. So remember, if we add 3 to this side, it will cancel out with this negative 3. So it will have a negative 3 plus 3, and that will basically cancel out. And that is how we have minus 2 plus 3 is equal to a half x. So now negative 2 plus 3, negative 2 plus 3 will leave me with a positive 1 is equal to a half x. And now we're going to go ahead and solve for x. So this half is being multiplied with the x. When it comes across to the left-hand side, it will basically flip our screen. When we're working fractions, it usually change the division sign to multiplication, then flip the fraction that follows. So this is one of those times. So it will be 1 multiplied by 2 over 1 is equal to a x, and therefore 2 is equal to x. So when f of x is -2, the value for x is 2. So when f of x is -2, what we find out is that the value for x is 2. And you can check if this is correct by inputting 2 or substituting x for 2 into the original formula to find out if f of x will be equated to -2. And that is it for part 2 of the question. Part 3 now says an ordered pair for the function An ordered pair for the function is expressed in the form AB. So from this part AB, this is our XY coordinates here. So it says use your answers to part A1 and A2 or otherwise, and list the ordered pairs for the function. So remember, up top, it gave us that the function, it had a domain of 1, 2, and 3. So this is what we're writing the ordered pairs for, the 1, 2, and 3. So when x is 1, what was the value for y? When x is 2, what is the value for y? When x is 3, what is the value for x? So that is what you're doing for the ordered pairs here. So what we know is that if you remember in part A1, when x was 1, because that is what we worked in part A1, it said to find out f of 1 when x is 1, or f of x had worked out to be -2.5. And our second ordered pair is when x is 2. When x is 2, that is what we just worked here. When x is 2, our y value was -2. Now we need to find out when x is 3. That we didn't work, so now we need to work that portion. So I'm now going to work f of 3. So that would be a half x minus 3. So what we have is f of 3 is equal to a half multiplied by 3 minus 3. What this will give us is, so this is just the same as in part 1. Part 1, they asked us to work out f of 1. Part 2, we worked out what f of 2 is, and now we're working out f of 3. So we can have all 3 ordered pairs. So now we're doing the same working. So what we have is f of 3 is equal to a half multiplied by 3 is 3 over 2 minus 3. And now we're going to work using fractions, finding our LCM to find out what f of 3 is equal to. So f of 3, our LCM would be 2. So therefore, 2 into 2 goes 1 time. 1 multiplied by 3 is 3. And 1 into 2 goes 2 times. 2 multiplied by 3 is -6. And when we do 3 minus 6, what you'll get is a negative 3 over 2. So therefore, f of 3 is equal to negative 3 over 2, which when we change that from an improper fraction to a mixed fraction, what we'll get is negative 1.5. So now going back to our ordered pairs, so we had up top already, when x was 1, our y value was negative 2.5. So that was our first ordered pair. For ordered pair number 2, when x was 2, y was negative 2. And for the third one, when x is 3, y is negative 1.5. And this is our 3 ordered pairs. So for those who are wondering, at the start of the question, it stated what are the functions or the f values, the domain values. Our domain values is our x values. So it says the domain values are 1, 2, and 3, and it is given by using this formula. All right, so part 4 says, explain why f of x is not equal to 5 for the function specified. So 1, we know that f of x is not equal to 5 because in the question, it goes up to f of 1, f of 2, and f of 3. So no mention was made of f of 5. So the domain was given and none gives rise to where f of x is equal to 5 because we worked out f of 1 and it gave us negative 2.5. We worked out f of 2 and it gave us negative 2. And we worked out f of 3 and it gave us negative 1.5. So therefore, at no point was f of x equal to 5. So therefore, the domain, which is our x values, was given, and at no point any gave rise to f of x being 5. And we can also prove this, as remember, the formula was f of x is equal to a half x minus 3. So if we replaced f of x with 5, so if we do 5 is equal to a half x minus 3, we're now solving for x to see if x is one of any of our values that was given in the question, because remember the x values that were given were 1, 2, and 3. So they're asking us, so now we're proving as to why f of x is not equal to 5. So what we have is 5 plus 3 is equal to a half multiplied by x. So this 3 was subtracting here, so to get rid of it or to move it to the left-hand side, we need to add 3 to both sides of the equation. So 5 plus 3 is 8 is equal to a half x. And now solving for x, it will be 8 multiplied by 2 over 1, as the half was multiplying. So when it comes across, it will be dividing. And we know we change our division sign to multiplication, flip the fraction. That follows, so we're flipping the half to get 2 over 1. And now what we'll have is 8 multiplied by 2 over 1, which is 16 is equal to x. No, at no point in this question did they tell us that 16 was a domain value. The 3 domain values that they gave us, which was the x values, are 1, 2, and 3, which was stated in the original question. So therefore, that is why this explains and this proved why f of x is not equal to 5. So there was no domain value that was given as 16, and that is why f of x is not equal to 5, and that is our proof right there. Part B1 now says solve the following inequalities. So we have 3x minus 1 is less than 11. So what we're doing is 3x minus 1 is less than 11. So it operates similar like equation. So what we're doing is making x the subject of the inequality basically. So we're doing 3x is less than 11 plus 1. So the 1 was subtracting here. So when it comes across the inequality, the operation changes and it starts to add. So now what we have is 3x is less than 12, as 11 plus 1 is 12. And then what we have is x is less than 12 divided by 3. And therefore x is less than 4. So that is our answer for A. 3x minus 1 is less than 11. This is it. So we have 3x minus 1 is less than 11. 3x, so now what we did here was to add 1 to both sides of the equation. When you add it to the left, it cancels out this negative 1 here, and that is how we have 3x is less than 11 plus 1, and now we have 3x is less than 12. X therefore is less than 12 divided by 3, as the 3 was multiplying here. When it comes across, it will be dividing, and therefore x is less than 4. And that is our answer. B now is 2 is less than or equal to 3x minus 1. So it is 2 is less than or equal to 3x minus 1. So what we have is 2 plus 1 is less than or equal to 3x. So we're adding 1 to both sides of the equation. So the 1, when you have negative 1 plus 1, it will cancel out here, and you have 2 plus 1. So 2 plus 1 is less than or equal to 3x. So 2 plus 1 is 3, is less than or equal to 3x. And now what we have is 3 divided by 3 is less than or equal to x, as the 3 was multiplying here. So when it comes across, it will be dividing. So therefore 1 is less than or equal to x. So 1 is the least possible value that x can be. So this is the same as x is greater than. So this is the same expression that is saying x is greater than 1. And that is our answer for part B. So part 2 now says represent the solution. 2 is less than or equal to 3x minus 1 is less than 11. So what they did here was the both inequalities that we worked up top, they joined it as one, and we're expressing it on this number line. So what we know is that for the first one, which was the 3x minus 1 is less than 11, we know that the answer had worked out to be x is less than 4. So we're going to represent, so this part, we're using this part of the inequality first. So this part right here, 3x minus 1 is less than 11. So when we had worked it out up top, we got that to be x is less than 4. Remember, when there's no equal to sign, when it's not greater than or equal to or less than or equal to, then the circle that goes above the number remains unshaded. And it is saying x is less than 4, which means that our arrow would have been going in this direction. The other one now was 2x is less than 3x minus 1, which is it right here that we just worked out. We just worked it here. And what we got is that x is greater than 1, greater than or equal to 1. So x, remember, when a greater than or equal to sign is involved, then we shade the circle. So when it is shaded, what it is telling us is that the number that the circle is above is a part of the solution. So x is greater than or equal to 1, so it is greater than or equal to 1, so it is going in this direction. So this is what your number line will look like. You'll have an unshaded circle above 4, a shaded circle above 1 with a line connecting them both, and that is our answer.